All right, guys, this is the lesson for 5.2 with more exponent rules. All right, so if we look at the example x squared over x to the fourth, you would use your quotient rule, right? So you would have x2 minus 4 equals x to the negative 2. We, in the world of mathematics, never have a negative exponent. Plus, what does an x to the negative 2 mean? It does not equal negative x squared. These are not true, so do not give me that answer. Rather than, let's go look at the beginning of the problem. This would be x times x over x times x times x times x. Okay, that would cancel, effectively leaving me this x squared on the bottom, and then I need a placeholder, which is a 1 on top. Okay, so we have a new rule. We have a new rule for negative exponents. That's the same as writing 1 over x to the n. Similarly, if you have this rule, you would rewrite this as x to the positive n. Okay, so again, but you only move the negative exponent. What's attached to the negative exponent? You do not move anything else, only the negative exponent. So, for example, the first thing we would use is our product rule. So that would become 1 to negative 2 over 2 to negative 2. All right, but I don't like negatives, so I'm going to take the 1 and put it down on the bottom, and that makes the exponent positive. And then that negative exponent down there on the bottom, I'm going to take it and put it on top. I'm going to change its size, and it becomes positive. 2 squared is 4. 1 squared is 1, so your answer is 4. Okay, here again, we like this rule. So you're going to take that x to the negative 4, and you're going to put it up on top. And it becomes a x to the positive 4. What about this? All right, you've got a couple ways to do this. So you can use your quotient rule. So you're going to have z to the negative 3 minus 2 equals z to negative 5, which then you're going to go and use your negative rule, exponent rule, and put that as 1 over z to the 5th. The way I really like to do it, is looking at the quotient rule and asking which exponent is larger. Okay, 2 is larger than negative 3, so I'm going to write this as, I'm going to put a 1 as a placeholder, and then I'm going to do z squared minus negative 3, which is 2 negatives make a plus, so that is 1 over z to the 5th. Okay, and there are multiple ways to do problems. Just find one that works for you. All right, here we go. Here's another one. I do not like this negative 5 in the exponent. Okay, so the negative 2, it stays in place. It does not move because it does not have a negative exponent, so it gets to stay where it is, and this becomes x to the 5th. Ooh, what about this problem? This is just a multi-step problem. So I'm going to use the power rule for this. So that's going to become x to the 3 times 5 times x squared over 8x, x to the 8, which is equal to x to the 15 plus our 2 over x to the 8. 15 plus 2 is 17, so that gives me x is 17 minus 8, gives me an answer of x to the 9. It's all right that these take multiple steps. Steps are great. Show your work. Don't get lost on these problems. All right, let's look at this problem. So I'm going to use my exponent power rule. to deal with this to start off with. So that gives me x to the 7 times negative 2 and y to the 6 times negative 2, giving me x to the negative 14 and y to the negative 12. Then I've got to use my negative exponent rule, so that becomes x to the 14th. Y goes down here to become positive, and I have nothing left on top, so I need to put a 1 in a placeholder. Another way we could have looked at this problem is we could have automatically started by putting this as x to the 7th, y to the 6th. Okay, I'm going to get rid of that negative right away and put that 1 right there. And then I would have 1 over 7 times 2 and y 6 times 2, giving me 1 over x to the 14th, y to the 12th. Okay, so again, multiple ways. I'm sure there's another way I have left out, but don't worry. Maybe you will do steps slightly different order, but you will all come up with the same answer. All right, let's look at this problem. X to the 5th and x to the 5th, they're going to cancel. So I'm going to draw my bar, and I'm going to look at my numbers first. Can I reduce 2 and negative 9? I cannot, so I'm going to leave it as 2 negative 9ths. I've reduced my x's. What about my y's? And I'm going to do it, I'm going to look for the largest exponent, which happens to be 9. So I'm going to leave it in that spot. So I'm going to do 9 minus 5. And then I'm going to look at my z's. Which one has the larger exponent? Is 0 larger than 3? No, 3 is larger than 0. So I'm going to put z to the 3rd minus 0. And then I'm going to simplify that. So that's 2 over 9 y to the 4th z cubed. And I have a negative. It could go in front of the 9. I'm just going to put it in front of the 2 because I like putting it on top. But it could be in front of the 9. It could also sit right here in front of the bar. Just make sure that it's clearly defined. All right, so I'm going to use my exponent rule. So I'm going to get x to negative 3 times negative 7. And then I'm going to have y to the 7th times negative 7. So that gives me x to the 21 times y to the negative 49. The only one I don't like is that negative 49, so I'm going to use the negative exponent rule to move it. And it's going to become y to the 49th. Okay, you could also do this problem as 1 over x to negative 3, y to the 7th to the power of 7, and continue on that way. You will still come up with the same answer. Try it. Okay. The other thing we have to cover is scientific notation. Scientific notation is a positive number written as the product of A, where 1 is less than or equal to A and less than 10 in an integer of a power of R. For the example, that's supposed to be an A times 10 to the R. So you might be given this problem, 430 million, and asked to put it into scientific notation. Okay, you're going to take your decimal and you're going to count 1, 2, 3, 4, 5, 6, 7, 8. It took me 8 spots to get over there, so it's going to become 4.3. So is 4.3 between 1 and 10? Yes, times 10. And my power is how many times did it take me to get over there? Which is 8. So the answer is 4.3 times 10 to the 8th. Same goes in reverse order. 1, 2, 3, 4, 5, 6. So you have 2.8 times 10 to the 6th. But because you went in you're making the number bigger, you have to put that negative there.